Welcome, ladies and gentlemen. My name is Jacob Barsha, and I want to thank you all for watching this presentation. We have a lot to cover in today's video, and I am excited. My team and I will be talking about what exactly a container is, the use and reasons for containers, the difference between containers and virtual machines, the different types of containers, what is Docker, and what are Docker files. So without further ado, let's get started.
Hello and welcome. My name is Josiah Pippin, and I will be guiding you through a basic rundown of containers in general before we dive into Docker specifically. So what we'll be covering today is what a container is, and then I'll talk about some benefits of containers and touch pretty briefly on container management systems. All right, let's get started. So what is a container? I think a good definition is a standardized unit of self-contained software. A little more explanation is necessary there. It's an application or a piece of an application that contains everything it needs to run on a system. That includes the code that makes up the application, as well as any configuration options or dependencies. We'll break it down a little further here. This is an analogy which I find helpful. If we look at shipping containers, they're a standardized way of moving goods across the world. And before they were invented, you had to find some way to lash things to a deck on a ship or bundle them in a unique way that met your specific needs. But if you can imagine trying to carry different goods on the same ship, that packaging could become hassle-some. If you're trying to put together rhinoceros horns, they're not going to fit well with a stack of oil casks. And how do you put them together? And how do you make sure you're not wasting space? How do you make sure you can easily find things? And probably most importantly, how do you move them easily to different means of transport? Shipping containers allow all of that easily because you could have the same container hold anything in it, and it can be moved around from ship to train to truck to helicopter. It doesn't matter. It can get around as long as it's in a container. Well, software containers are much the same way. They use space well, they take care of themselves, meaning they have everything they need to work, and they're meant to work wherever they're put because they have all their dependencies baked in, so they can be moved from server or deployed on a server or a personal computer, your own laptop, anything. As long as they're meant to work on it, they will. Now, some examples of container solutions would be Docker, which we'll be talking about today, and that's definitely the go-to at the moment in the container world, or CoreOS's Rocket, or Mesos, Apache's Mesos containerizer. It's a huge market. It's growing daily. So there are plenty of up-and-coming containerization solutions, and you can keep your eyes on them going forward. But we'll talk about Docker mainly today. So what exactly does a container look like? Well, an individual container has within it its own code, as you might expect, but it also includes any dependencies, libraries that would need to go with it, its own runtime engine, and its configuration options. The point of all that is so that, as you can see from this containerized application little diagram here, that you only need the infrastructure and the host operating system. But beyond that, on a computer that a container is installed, it needs a container engine that will activate containers and instantiate them and track them. But each individual application that's containerized has everything it needs to run. It has the instructions, it has the code itself. It is an independent entity, still run on its host operating system to better utilize those resources, but at the same time, it's meant to just work by itself and work the right way. So what? So we have these cool containers. We know a little bit about them, but what do they do for us? What are the real benefits? Let's look. Some reasons why containers are awesome. They run anywhere consistently. They will save you resources, particularly when compared to virtual machines. They enable the microservices model, and they're well scaled. Their scalability is simple, or at least it's easily suggested. So let's break these different things down a little more. The idea that they run anywhere consistently is it's a core facet of containers and why anyone cares. It goes back to that idea I described, much like shipping containers can be moved anywhere and it works via helicopter or train or ship. Same thing with software containers. I can put it on my machine at home, or I can run it on a server. You don't run into that sad problem where you've probably come across this before. You say, it works on my machine. That's not a problem anymore, because unlike those instances where it works on your machine, it doesn't work on the person who you're talking to. Containers have everything they need to run the same in each environment. More than that, because they contain all the stuff they need to work, it's not just that they're consistent, they avoid failure on different systems because there are no missing resources. You won't see a window popping up saying, hey, your DLL is not included, I can't find the class library I need to run this. It protects you from future updates. It makes sure that your container solution doesn't outdate itself because of some change in the system that's running it. Now, it saves resources as well. Containers are quick starters, and they're much less resource intensive than a virtual machine. Now, I won't steal the thunder from a little later about what the differences are between containers and virtual machines. Basically, there's no machine and OS to recreate on a container. It's running on the OS that it's on. It doesn't try and add that bit of functionality. It doesn't pretend as if it's another machine. If you could sort of think of it as, we're talking about shipping containers being on a boat. If you put shipping containers on a big old barge and you go from China to America, you can put a lot of them on there. It's a great deal. You can stack a bunch of them on there, and that's akin to the container model. But a virtual machine model is a little bit more like having containers on little boats that are on a big boat and trying to take them over. You lose space. As cute as that sounds, you can tell that you're wasting resources on making these little boats that hold on to the containers rather than just putting them on the one boat itself. Another big plus of containers is that it enables microservices. A microservice is just a name for a model of software development where you, instead of having one big monolithic application, you're breaking down its component parts into separate services. So whereas you would have, let's say, an accounting software piece, and you've got sales and you've got inventory, a separate system, as one united system that has to depend on each other. If you're using a microservices example, and this is grossly blown up because you can split it much further, but you could separate those systems so that if there was a failure in one, it wouldn't affect the other. Or more usually, if you wanted to develop in one, you wouldn't interfere with the other. It makes development faster because you can independently work on different parts, and you can upgrade more swiftly, and it allows all sorts of modular application. If you want to add to an application, give it another service or another ability, by using a microservices model, containerizing your different parts, that's much easier because you won't break anything by adding new things to the application. Now, scalability, another big benefit. You're growing to meet consumer demand. If you have a product and you need a separate container for each person logging in to use your Cats Are Awesome video montage app, and then you suddenly become an internet sensation, you do a Flappy Bird, well, now you suddenly have to have more containers deployed at once. And with a containerized solution, since they're isolated and each bit of functionality can be recreated, then you can deploy easily many more containers than you need. And then once you contract in user base, then it's not as if you have to shut down virtual machines or register them, particularly with a content or a container management system, which we'll get to in a moment. You can shrink and grow very easily because containers themselves are meant to be easily replicated and easily destroyed. So I mentioned this, container management systems. A container is pretty great as a solution, but it's granule, and so you're dealing with a bunch of these little things, these bits of functionality. So it can be difficult on your own if you have a complicated application to keep track of how they interact together. And normally that would be a benefit of a monolithic application because that's how it works by default. But a container management system allows you to have that cohesion of a monolithic application and still use containers. So it controls things like scaling for you, and it does group and administration of containers, grouping them together and finding out how to better utilize your machines, whether they be virtual or real. Um, It'll recreate and find damaged containers. It's always scanning your system to find something that's out of place, and it has a document that tells it exactly what each container should be like. So we can recreate them on the fly without the application going down, and then get rid of the old and then put in a new container, because containers are so simple and quick to put back up. And then updates. Container management software will continually apply any update that you have to any containers that you have in the running, um, so that you don't have to worry about applying your update to who knows how many containers. If you're running 2 million of them in a given day, it'll take care of that for you. So it's two big names in the container management software arena, though many keep cropping up. It's sort of a daily thing. Kubernetes from Google, and then Docker's own Docker Swarm. So we've talked a little bit today about containers, what they are, why they're beneficial. Containers are a huge part of the software development world, and we don't know what the future will hold, but for right now, that's where it's at. There's so much cloud-based software work, and containers are so well suited for it because of how they separate out individual functionality, that they're used throughout the development world. Google uses them hugely, Amazon Web Services, Infosys, and Intel, Red Hat, Hawaii. There's so many more that could be added to this list. It's a go-to if you're using anything as a service, or you're creating software that has to be accessed from the cloud. Google itself, at last count, creates over 2 billion containers in a given week. So without further ado, I'm going to pass the baton to our next area of conversation here, which is containers versus virtual machines. All right, stay tuned.
So now we're going to talk about containers versus virtual machines. Are containers the wave of the future, or are they just a fad? What is a virtual machine? So basically, virtual machines are a type of emulation of a computer. They make it possible to run what appears to be many separate computers on hardware that is actually only one computer. It saves businesses money, it saves businesses space, as in the space to prevent rooms full of computers. What are some of the requirements of virtual machines? So each virtual machine requires its own underlying operating system, unlike containers, which share the host operating system. And the OS and hosted applications share hardware resources from a single host server or a pool of servers. So it can share hardware and operating system resources from multiple different physical machines. So everybody can pool all their physical resources together, and we can divvy them out. So, and as you see in the picture on the left here, you can see that you are in it's kind of outdated, but it is a Windows XP computer that is remoting into 4 separate virtual machines, and they all look like different operating systems. So one's Linux, one's Mac OS. I think there's another Mac computer, a couple Linux machines, but the Mac operating system is basically a Linux machine anyway. So So it just gives you an idea of what you can put on virtual machines. So technically right here in front of you, you see 5 separate computers, but it's really run on one single machine, physical computer. And here's a little on the left, or I'm sorry, on the right, there is a little diagram here that kind of explains that a little further, gives you an example. So you have a physical machine with 12 terabytes of RAM space, or I'm sorry, hard drive space. And then you have a CPU with 10 cores. You have 48 gigs of RAM. And so you are sharing all of that physical resource, all of that hardware resource amongst 3 different virtual machines. So you allocate 12 gigs of RAM, 2 cores of CPU, and 2 terabytes of space to the first one, 16 gigs of RAM, 3 cores CPU space, 3 terabytes of RAM to the middle one, and the last one will get 18 gigabytes of RAM, 4 cores, and 5 terabytes of physical space. So that's all virtualized hardware, and you can, on the fly, change all those numbers as needed. So a hypervisor is used to create and run virtual machines. So the hypervisor basically takes the hardware and software and makes a virtual copy of it, which allows the creation of a virtual machine to allocate and use that specific hardware that you assign to it. And so you have hardware level virtualization, and that helps with the hypervisor. Or excuse me, the hypervisor helps with it. And then you have a quick VM and container comparison. So as you see on the left here, the virtual machines, starting from the infrastructure, which is basically the hardware. You have a host operating system, so your main operating system, and then you have a hypervisor, which allows the virtualization component, and then you have your 2 App1 and App2 virtual machines. So they both require a guest OS. They both require binaries and libraries, and you have your 2 applications. And then on the other side, you have the container, which requires hardware of some kind, a host OS, and then a container manager, which is basically a replacement of the hypervisor. And the containment manager essentially allows the sharing of the operating system with the 3 containers you see there, A, B, and C. So when virtual machines first became a thing, they were very expensive because it wasn't widely used, and they knew it could save people a lot more money, and so they kind of gouged people a little bit until it became more affordable. So now it's very affordable. It's possible for it to take up a lot of resources, but you know, you could spend more money, get more RAM, and you'll be fine. It is more economical compared to running separate physical computers, of course. So you have one of these racks here. This is kind of what it looks like at Munson in the downstairs server room, this picture here. And one rack can hold a couple hundred virtual machines. So one of these little slots, if you can see through the very first one here, you can see two machines here. They're stacked on top of each other. So one of those is a server unit, and one of those could potentially hold a couple hundred virtual machines, and one of those could be anywhere from $1,000 to a few $1,000s in cost. So it's not cheap, but it's not super expensive for what it can do. Each virtual machine takes a few minutes to start up, so it starts just like any other Operating system, you gotta turn on the computer, let it do its boot up process, the post and everything, and it's gotta just start up like any other computer. I mean, nowadays with SSDs, solid state drives rather than hard disk drives, things boot up a lot faster, but it still takes a little while, at least compared to containers. Sometimes a virtual machine can be overkill for applications. So if you have a tiny application that basically can run on a toaster, a virtual machine is overkill. But sometimes if you don't have containers, you need to use a virtual machine. And so to use those, containers are really good for applications that don't take up a lot of resources. So, but if security is your main feature, like it is in the hospital, then full isolation is needed, and you get that with virtual machines. So you get full virtual machine isolation from each other virtual machine. So just because you have 200 virtual machines on one physical box, none of them, unless made to, can communicate between one another. So here are some of the virtual machine providers. You have VMware, VirtualBox, Xen, Hyper-V, KVM. I've heard of KVM and Xen. I've used VMware, VirtualBox, and Hyper-V. They all kind of work the same. You basically pay the company for however many virtual machines you want, and then you're allowed to make and maintain as many as you're allowed, which is kind of cool. So containers in comparison to virtual machines. So containers use primarily operating system virtualization as opposed to hardware virtualization. It uses the host operating system, and it shares the host operating system's resources. So it's very light, megabytes in size usually. It takes seconds to start up rather than having to... It's like opening an application versus restarting an entire computer. That's kind of the comparison in time for boot up. And you can hold 2 or 3 times as many applications on a single server than with virtual machines. And again, virtual machines are fully isolated while containers have process level isolation. So basically, you open up a container, it's separate from another container. And that's it.
Hi guys, this is Jacob Barchef. And now that we kind of talked through containers and how containers differ from virtual machines, we're now going to get into actually talking about Docker. So what is Docker? Well, Docker is the name of a company that released Docker Engine in 2013, which is an open source project that enables the creation, deploying, and running of container-based applications. So as we talked about before, Docker is very similar to a virtual machine, but it's also different. Rather than creating the whole virtual operating system, Docker allows applications to use the same Linux kernel as the system that they are running on. And it really only requires applications to be shipped with things that are already not running on the host computer. Docker products include the enterprise and desktop development environments, Docker Engine, and Docker Hub, which is a cloud-based repository, much like GitHub. And just some of the companies that use Docker include PayPal, Visa, and Expedia, just to name a few. So like I mentioned, Docker has multiple products, and 2 of these include Community and Enterprise. Both Community and Enterprise include the Docker Engine, support for Windows, Mac OS, and Linux, and then support for any language or framework that the developer chooses to write the applications in. Enterprise is really geared towards production level applications. Some of the benefits include MSI package installers, technical support with an SLA from Docker itself, and customizable application templates that Docker provides. So really, some of the main benefits of Docker Enterprise include running certified Docker images and plugins, receiving vulnerability scans on your Docker images, and like I said before, getting official same-day support with that SLA. But really, both community and enterprise allow you to create and run containerized applications. So the other product that Docker offers is Docker Hub. And this is the GitHub for images. It's a cloud-based repository that allows you to push and pull container images. Some of its features include teams and organization. It allows for private repositories so that teams can work on projects together. There are official images provided by Docker that you're allowed to pull and run. And then it also features automated builds, which is the process of building images from source code and an external repo. So Docker, what is an image? Well, an image is the instructions to build a container. It is built by the sequence of commands found within a Docker file. So the process or sequence kind of goes from the Docker file into a Docker image, and then the Docker container, which is the running instance of an image. The basis for a container is the image itself, and images can be multi-layer, with each layer building upon the other when commands are executed within the Docker file. So that is just a little bit about Docker, just touching really briefly on that. Now we're going to get into talking about Docker files from Teresa.
Hi everyone, this is Teresa. I'm here to give you an introduction to Docker files. So a good place to start is going to be a definition of a Docker file. A text document including commands a user can call on a command line or a terminal to define a Docker image. And the role of a Docker file is to give commands that are instructions given to a Docker engine one by one and performed in sequential order to create an image. Essentially, the commands are used like a recipe to create the layers of a Docker image. You would start with a base image, which you could possibly pull off of the Docker registry, pull existing software or files needed for the container, expose any necessary ports, define the environment within the container, whatever you need to accomplish in that specific image or container would be handled in the Docker file. So let's look at the architecture of Docker for a moment to visualize what's happening with the Docker file. First, on the left, you have the client, which is on your local machine and has your choice of command line interface or the Docker API that's included with the Docker installation. Those tools will help you communicate with the Docker host or the server running the Docker daemon. Frequently, that is on a virtual machine. The client can pull images from the registry via the server, build an image, which the server would run as a container on the host. Each layer has a unique identification, and it's only stored once on a host, saving you resources in storage and transfer time back and forth between the client and the host. So here are some basic commands to build a Docker file. This is not a comprehensive list, but this is just something to get you started in building your own Docker file. The from command would be used to set a parent image used as a base image when composing a Docker file. Again, those parent images or the base images can be pulled frequently off of the Docker registry. If you are creating your own base image, this command would not be something you would include in your Docker file. The copy command copies the current directory contents into the container, the current directory on your local machine. Run command installs necessary packages or executing given commands. There's quite a bit involved in this particular layer. which we're not going to cover in this presentation. We probably see a little more in Wyatt's presentation here next. Expose exposes a port to the world outside of the container. Environment command can be used as a sort of version control, specifying required environment variables on services that you want to containerize. This is specified as a key value pair. A command specifies a command to run once the container is run. Only the last command instructions will be run, so obviously it only makes sense to include one of these per Docker file. The stop is pretty self-explanatory. It's a command to stop a running container. Next, we have a brief example to take a look at. It includes most of what we just talked about. We start with your from, so we use a Python runtime as the parent image. Next is working directory, which we didn't talk about, but this is a pretty common command in the command line environment, basically. Just set your working directory that you want to be pulling your files from. Copy, you have your period here, which specifies use the current directory to copy files from. Run, you're installing pip. There's some other flags here that I won't get into, but you'll probably see a lot more flags with Wyatt's presentation. Expose is expose 80, so that's exposing port 80 to the world outside the container. Environment, just environment name is world. And command, you're running Python and app.py when the container launches. Lastly, we'll just take a look at the basic representation here of the layers represented in a Docker image and a Docker container. So on the left is just a representation of the layers of an image. It's a read-only image composed of the instructions from the Docker file. Each one of these has a basic ID listed here with the file size. The base layer is Ubuntu. On the right is a running container. It has that additional layer that is read-write on top of the image layers. So again, this is just my basic introduction to Docker files. I hope this helps you to get an understanding of how that works and the basics that you need to get it started. Thank you.